take a look at 2.1 Part 2. Part 2 is on two things. Okay, so just to kind of show you what we're going to do. I'm going to be giving you a circle. We're going to have an angle inside it, and I'm going to want you to measure how long that arc in red is. And that arc in red is going to depend on two things. How big did you make that angle, and then how big is the overall circle. Right, so we're going to look at how you find the length of an arc. And then the other thing we're going to look at is how you find the area of that section in blue. Okay, it's not a triangle. It's close, but
what shape is it called?
it's called a sector. Yeah, it's like a round piece of pizza cut into like 8 slices or 4 slices. That's the shape of it. So two sides are straight, one side is curved, and that's called a sector. And I'm going to give you the formula for the area of a sector.
Is the definition of a triangle 3 straight sides, or is it just?
Yeah, all the sides have to be line segments in a triangle. Yeah. Yep. All right, so let's start with this picture. In this picture, I've drawn 2 angles inside the circle. When we don't know an angle in trig, we usually label it with that Greek letter. That's theta, T-H-E-T-A. I don't know what the angle is, so I'm just going to call it theta. And then that's an S. Okay, that arc goes with that angle. S1 goes with theta 1. So we have 2 different angles, and then we have 2 different arcs created. And R stands for radius. Yep. All right. So what we're going to want to do is come up with a formula to find what's called arc length. That's the thing in red. That's an arc. Now, in order to come up with a formula, we have to start with something, right? Like if I wanted to come up with a formula to convert feet to inches, okay, I use that because it's familiar to most people. I know in 1 foot, there's 12 inches. So then I could come up with a formula in x feet, there's y inches. If I cross multiply that, I could get a formula that I could use to convert feet to inches. So for example, if you wanted to convert feet to inches, the formula would be times 12. Take the number of feet, multiply it by 12, and that'll give you inches. If you want to convert inches to feet, you divide by 12. But the key is if you don't know that 1 foot has 12 inches, you wouldn't know to multiply by 12 to convert feet to inches. So you've got to know something to start with. Once you have that, then you can figure out whatever you want. Okay, so this is what we have to figure out. We have to figure out something that we know is true in that diagram. Okay? And the reason that what we're going to figure out is true is the same reason 1 foot has 12 inches. It's a definition. Okay? You don't prove that 1 foot has 12 inches. It's just that's how it's defined, right? So we're going to come up with something like that right here. Now, just because I'm supposing in this problem with a 1 and a 12, does that affect what numbers I can put on that side? No. Okay, bless you. Just because I picked a 1 and a 12, that doesn't limit. I can put a 9 up here and solve for how many inches in 9 feet. I could put a 3, find out how many inches in 3 feet. These 2 numbers are just a true fact. It can be any true fact that you want. Okay? So let's see if we can come up with a true fact here. Let's suppose that theta 1 was a certain size. All right? Just like we supposed 1 foot equals 12 inches. If this angle is a certain size, then it will automatically make this a certain size. We learned that yesterday. Does anybody remember how big this angle has to be, and then this arc comes out the same as something else in that picture?
2?
So if this angle is a certain size, then it's going to make this the same as something else.
The radius.
The radius. This and this will come out the same if that is how big?
2?
No, not 2.
Oh, isn't it like 1?
1, yes. If that angle is 1 radian, then the arc will automatically equal the radius. And why is that helpful? They're going to give you the radius in the problem. So we're going to be able to use that.
In degrees, I assume.
Well, the angle they could give you in radians or degrees. We'll do some in radians and then we'll do some in degrees. Okay? So if theta 1 is 1 radian, then that arc is automatically the same size as the radius. Why? Why is there 12 inches in 1 foot? That's the definition. All right, so now we're going to plug in that information into a formula. All right, so let's look at what the formula is going to be. Let's start by looking at this circle. How big is that angle?
90 degrees.
It's 90 degrees. Now, look at that arc in red. How much of the circle does that arc take up?
A quarter of it.
The arc takes up a quarter. Right? Now, let's look at another picture. Another circle. Let's draw that angle. And let's look at that arc.
180 and a half.
Okay. How big of an angle is that?
180 degrees.
It's 180 degrees. So before we look at how much the arc takes up, what did I do to the angle in picture 1 to turn it into the angle in picture 2?
Doubled it.
I doubled it. I doubled the size of the angle. What I want to see is if I double the size of the angle, then does the size of the arc double as well? If it does, then that's called proportional. That means as the angle changes, the arc changes exactly the same way. So when we doubled the size of the angle, we got 180. How much of the arc does that circle, or how much of the circle does the arc take up? It does take up a half. And if you double a quarter, what do you get? A half. So if you double the size of the angle, then you also double the size of the arc. If you triple the size of the angle, then you would
Triple the size.
triple the size of the arc. If you make the angle half as big, you make the arc half as big. They change together. That's the point. Okay? And that's called directly proportional. When two things are proportional, you can set up a proportion. Okay? Proportion is where you have a fraction on each side and an equal sign between them. You can't set up something like this unless you know for sure that things are proportional. But we just checked that. They are. All right, so let's set up a proportion. And for now, it's just going to have 4 variables in it. This one, this one, this one, and that one. An arc, an angle, an arc, and an angle. Okay? It's going to be kind of like this. We're setting up a proportion, and one side we're going to know some stuff. The other side, we're not going to know stuff. Okay. There's lots of ways you can set up the proportion. You just have to do it the same way on both sides. Let's start with, Will, can you shut it? Thanks. So let's start with theta 1 and S1. I'm going to write down theta 1, or actually I said theta.
Are you saying theta?
Theta.
Theta. T.
So on the left side of the proportion, I'm going to put these 2 things. I could have put any of those things circled in blue. I could have put any of them. It doesn't matter which 2 I put. What matters now is when you set up the right side, you set it up the same way as the left side. That's an angle. That's an arc. So set it up the same way over here. Angle, arc. So what would have to go on the top on the right?
Theta.
Would have to be a theta. And on the bottom,
S.
an S. That's the proportion that describes those 4 things.
But they're not the same. I don't know how they equal each other.
But they're proportional. So if 2 things are proportional, you can set them equal to each other in a proportion.
Wait, so what is proportional, like 2 times, 3 times?
It means that as one thing changes, the other thing changes exactly the same way.
How do we know it's proportional? It's just-
That's what we just looked at on the other page, right? If you double the size of the angle, you would double the size of the arc. I'm not saying those two fractions are exactly equal.
Well, yeah.
You could have something like this. We're not saying that the two fractions are necessarily identical. We're saying they're proportional. So one fraction might reduce to turn into the other one. Does that make sense?
Okay, so.
Yeah.
Okay.
We're saying that the two fractions are proportional, which means one could be a larger version of the other, like 2 over 4 and 20 over 40. Okay? But they're going to be in proportion to each other. Now, take our proportion and fill in this fact right here. Let theta 1 equal 1. So we're going to change that to a 1. And let S1 equal R. This fact right here is like my 1 foot equals 12 inches. An angle of 1 radian is automatically the same size. It makes the arc the same size as the radius. Okay? It's not as familiar as 1 foot equals 12 inches, but it's the same idea. An angle of 1 radian means the arc is the same as the radius. That's a definition. So fill that in. So for theta 1, fill in a 1. For S1, fill in an R. That's the true fact that I'm starting with on the left. Angle of 1 gives you a size that's the radius. Now the right is what I don't know. That's information that they might give me in the problem. Now when you have a proportion, does anybody remember how you solve it?
You multiply the other,
How do you multiply?
the top and the bottom. Isn't it cross multiply?
Cross multiply. If you cross multiply, what's S times 1? 1S. And then what's R times theta?
R theta.
Just R theta. And that, I'm just going to move that over here, is the arc length formula. So that's the formula that we need to use to find the length of an arc. And it comes from cross multiplying in the proportion. We're not going to have to cross multiply again. We've got the formula now. We're going to use it. So S is the arc length. What do you think R stands for?
Radius.
Radius. It's the size of the circle that you're working with. And theta is my angle. Yep. And something very important about the angle. What did we assume about theta 1?
It's 1 rad.
1 radians. It has to be in radians. Bless you.
God bless.
Kind of like when we set up this formula, we assume feet. So if you wanted a formula that converts miles to inches, well, that's not this. We assume the unit was feet. So here, we assume the unit was radians. So that's the arc length formula. Okay. The way the formula works is they will always give you 2 out of 3 of those letters. Plug in for the 2 that you know, and then find the one that you don't know. Okay. So let's try this one. When they give you a problem, they can either write it out, like I did in words, or in the next one, I'm just going to draw a picture. So the question is to find the length of an arc. So they're telling you that you've got a circle. Inside the circle, you have an angle of pi over 3 radians. And the radius of the circle is 4. All right, so what are we finding? Okay, here's your circle. You have an angle inside it. Just like that. It's pi over 3. The radius of the circle from here to here is 4 inches. And you are finding the length of this part in red.
What's and a radians of 4 inches? Or a day?
Radius, the same radius.
This way right here?
Yeah, I
Oh.
thought it was an M.
Oh yeah, radius. Yeah, it looks kind of like a weird M. All right, so first thing we have to do is figure out what our formula is. When they're asking about arc length, it's S equals R theta. Let's fill in everything we can. What am I going to fill in for S? We don't have that, right? That's the question. Find the length of the arc. We're not filling in.
4 times pi over here.
Yep, so 4 times pi divided by 3.
So
If
that
you-
is the angle?
Pi over 3 is the angle. Yep.
Can we do this on the calculator or no?
Not unless they ask for a decimal. Okay. Now, one thing we should have asked about the angle. What was the unit on the angle?
Radians?
So it already was the unit that it needed to be. Okay. If it was degrees, we would have had to fix it, but it was all set. Now multiply straight across. 4 times pi gives me, and in the bottom? 3. Now, what did we just find?
The arc length?
The arc length. So that needs a label on it. What would be the label we would put on that since it's a length?
Radians?
No, radians does not measure length. Radian measures an
A
angle.
degree?
Degrees also measures angles.
Inches.
Inches. Okay, it's not always inches, but this particular problem measures length in inches. So S is a length, R is a length, theta is a radian. And that's the answer. Now, if they said round your answer to 2 decimal places, then you'd put that in on the calculator. And that's it. Any question on that one?
It's not terribly hard.
Okay, let's try this one. So, same question. Find the length of that arc in red. So they're asking about arc length, so start with the formula. Okay, what's the formula we need?
S equal to R theta. We have to convert the 130.
We do. Yep. So before we can plug in for that, we have to convert this 130 to radians. If you don't, then that formula won't work. You'll get an answer, but it's not right. All right. So 130 degrees, we'll do it off to the side. What do you multiply by to change that to radians? Pi. And what do you
And then
do?
180.
And divide by 180. 130 and 180 are divisible by what?
10.
Yeah, so we could cross off the 0. I'd just leave it as 13 pi over 18. That's your angle. Okay, what's my radius?
8 feet.
8 feet. And my angle? 13 pi over 18.
And then you can put 8 over 1 and multiply across.
So the only thing we can do here is we can reduce.
Oh.
What number goes into 8? 4. So what number goes into 8 and
2.
18? 2. So 2 goes in 4 times. 2 goes in 9 times. What's 4 times 13? 52. Don't forget the pi is still there. And don't forget the 9 is still in the bottom. And what did we just find?
The arc length.
We found the length of the arc. So what should I put for a label on that?
Feet.
In this problem, it's feet. Because my lengths were in feet. All right. It's a little bit harder than the first one because you had to convert it, but still same idea.
So would you give a question on the test that's like starts off in feet, but you want the answer in inches?
No.
Okay.
No. If I give you feet, we'll keep it in feet. All right. Let's try this one. So we have an arc length of pi over 4 and a radius of 12. Okay. What letter does the pi over 4 get plugged in for?
S.
That's my S. So the question this time is not find the arc length. The question is find the angle. Okay, so we got pi over 4. What is my radius?
12 centimeters.
12 centimeters. I'm not worried about putting the unit when I do the work. I just need to make sure if I need it, I'll put it on at the end. And what about my angle?
Theta.
Theta, we don't know. Okay, how would you get theta by itself there?
Divided.
Divide
Yep.
by 12.
Divide by
12.
12. Dividing by 12 just means put a times 12 in the bottom of the other side. Okay, when you divide by 12 there, that's gone. And what do we get for an angle?
Pi over 12 times 4 equals angle.
So pi over
48.
48. And what are the units on that?
Centimeters.
Well, what did we find?
Oh, wait.
Centimeter.
No,
Oh, the
it's
angle.
It's a degree.
It's a
No.
radian.
It's a radian, right? We found the angle, and this formula always gives you the answer in radians. So should I put RAD?
You can, but you don't have to.
Yeah, we don't want to. Yeah. So that's how you'd see the answer written. On the test, it wouldn't even be an option to let you type RAD. Just pi over 48. The pi symbol will come up for you right in the box. All right. Any question on that one? All right. So we've tried finding S. We've tried finding. Oh no, we just did theta. Now let's look at finding the radius.
Would we ever have to find more than one?
No, you have to be given 2 to do it. If you're only given 1, that's not enough information. All right, so I got the formula. What's the first thing we'd have to do here?
Convert 36 to radian.
Okay, so let's convert 36 degrees into radians. And 36 does go into 180 evenly. How many times does 36 go into 180?
5 times.
5 times. So that goes 1.
Pi over 5.
So my angle this time is pi over 5. Yep. Okay. Did they give me S?
Yes.
Yeah. What did they tell me S is?
13.
13 feet. Did they give me R?
No.
Nope. Did they give me theta?
Yes.
And what's that?
Pi over 5.
Pi over 5. Okay, so now we want to get R by itself. So we want to get rid of the pi and the 5, and we can get rid of both at the same time. Does anyone remember what you have to do on both sides to get rid of a fraction next to a letter?
Over pi.
Yep, multiply by the reciprocal. 5 over pi. That cancels the 5's, and it cancels the pi. Multiply by 5 over pi. 5 times 13 is going to give me how much?
65.
65 over pi, and that is my radius. What do I need for a label on that?
Radians. Oh, no. It's
Feet. Remember, R is the distance from here to there. So feet. And I don't think we did this today, but if you want a decimal for it, you just type in 65 divided by pi. So it's about 20.7 feet. All right. So any questions on the arc length formula? Okay. So the last one is
area.
the area formula. Yep. Let's finish up with that. All right. So the first thing I want to look at is the connection between the size of the angle and the size of the area. Are they directly proportional? Okay. How big is the angle in that picture?
A.
90.
Where?
How much of the area is that shaded red section?
1/4.
That's a quarter of it, yep. What's the size of the angle if I double what I had before?
180.
180. So we're going to double the size of the angle. The question is going to be, do you double the size of the area? So that's angle is 180. I doubled it. Now by doubling it, look at the area that's shaded in now.
1/2.
That is half the circle. So if I double the size of the angle, I also doubled the size of the area. What if I were to triple the size of that angle?
It would triple.
I would triple the area. So the answer is yes. The size of the angle and the size of the area are directly proportional to each other. You make the angle half as big, you're going to make the area half as big. Because they're proportional, we can set up a formula that's what kind of formula?
Proportion.
A proportion, yes. And we can set up the proportion basically any way we want using those 4 letters. Just however you do the left side, you need to do the right side the same way. Okay. Somebody tell me what I could put on the left side.
A1 over theta 1.
Okay. So she did an area over an angle. The other side now has to be the same way.
A over theta.
A over theta. Now,
Cross multiply.
we're going to cross multiply, but we need something first. We've got to get our 1 foot equals 12 inches. We've got to plug in something we know is true on one side. Okay. So we had this circle, we had this circle. Let's go even bigger. Let's say we had this. And I have my initial side here and my terminal side here. So now
Greater.
I made the angle so big that it takes up the whole circle. How many radians does it take to go all the way around the circle?
More than 1.
Definitely more than 1.
Like 3.
4.
No.
It's over 3.
2 pi.
Oh.
Yes. So if the angle is not 90, not 180, but it's 360, 2 pi, then the area becomes what? If it's that blue section is how much of the circle?
100%.
100%. It's the whole thing. What's the formula for the area of the whole thing of a circle?
Something with pi.
Something with a pi in it. Remember?
Does it have to do with the radius?
It also has the radius in it. But
Pi times the radius doubles.
1/2.
Squared.
squared. Yep. So this is your 1 foot equals 12 inches. That's a true fact. If you make the angle go all the way around the circle, then the area will be the entire circle. And the area of an entire circle is pi r squared. So we're going to fill that fact in on this side. That's going to be the true side. And then the other side is the stuff we don't know. We can cross multiply. So let's change A1 to pi r squared
Over 2 pi.
over
yeah.
theta 1, which is 2 pi. And the other side, that's what would be given to you in the problem. Now, before you cross multiply, does anybody see what cancels on the left?
I.
The pi.
Oh.
Yep. Pi in the top, pi in the bottom. So now cross multiply what you have left. What's a times 2?
2a.
2a. And what's r squared times theta?
R squared theta.
Yeah, just r squared theta. So now we almost have a formula for a. We have a formula for double a. How would I get rid of that 2?
Divide 2.
Yeah, divide by 2 or take half of each side, same thing. So by cross multiplying, That's the formula that we get to find the area of any shaded section depending on the size of the angle. Could be a quarter circle, could be a half circle, could be a full circle. Full circle is the easiest because it's just the whole thing. But that's called the area of a sector. Did I write that? Yeah, I wrote that up there. Area of a sector. What do you think the A stands for?
Area.
Area. The R is my
Radius
radius. And theta
is the angle.
is the angle. But remember, we assumed the angle was in what units?
Radians.
It was radians. So this formula works just like the other one. They're always going to give you two things. You fill them in, you find the third. Don't know if I'm going to have enough time to go through all of them, but we can probably do at least one or two. All right, so now you have a choice between which formula to use. The only way that you know what one to use is to read what they want to know. What do they want to know?
The area.
They want the area, so you need to use the area formula.
Then we don't have to convert it, right?
There's nothing to convert here because the angle is already the way you want it.
Yep.
So what's the formula for the area?
1 half r squared theta.
Yeah.
Area equals a squared plus b squared. I'm just kidding. That was a joke.
All right. Did they give me the area?
No.
No, that's what they want me to find. So don't fill in for A. Did they give me the radius?
Yes.
Yep. How much?
4.
Did they give me the angle?
Yeah.
How much?
5 or 6.
Pi over 6. Okay. What's 4 squared? 4 times 4?
16.
16. What's half of that?
8.
So it's 8 times pi over 6. What does 8 over 6 reduce to? 4 over 3. And now that's an area. It's an area. What should be my label because it's area?
Or squared.
Centimeters squared, yes. Centimeters would be length. Centimeters squared is an area. Yep. Any question on that one? Let's try this one. So find the radius. What do you notice right away about the information they've given you?
They give us the
We need to use the
area.
first formula.
We need to convert the degrees to
Yeah, we've got to convert that degrees to radians. Okay, I'm just going to tell you what it is. But if you multiply by pi and divide by 180, you will get pi over 4. Now, how do you know whether to use the first or the second formula?
When they don't give you the area.
Yeah, what did they give me here?
The area.
Yeah, how do we know that that 8 pi over 3 is area?
Because it's inches squared.
That's how you know it's area. So use the formula for area. Okay.
23.
6 minutes. 6 minutes. Did they give me the area?
Yeah.
Yep. What is it?
8 pi over 3 inches squared.
Good. I'm going to have to erase this 45. I'm going to need some space. Did they give me the radius?
No.
No. Did they give me theta?
Yes.
Yes. What is that?
Pi over 4.
Yeah, pi over 4. Thank you. Okay, so now let's start to combine like terms on the right side. Actually, you know what? Let's move things to the left side. How could you put this 1/2 on the left side?
Multiply by 2 over 1.
Yep. So multiply by 2. That's going to cancel there. Multiply by 2. And what do you get on the left if you multiply by 2?
16 pi over 3.
Okay, so that's better. We're trying to get r by itself. And we at least got rid of the 2. how can I get rid of the pi and the 4 at the same time?
Turning off the screen.
You can multiply by a specific.
Multiply by,
4 over pi.
yep. Okay, so multiply by 4 over pi. That gets rid of both of those at the same time. And when you multiply by 4 over pi, it also cancels the pi's on that side. What's 4 times 16? So 64 over 3. So we're close to the radius. Right now we have the radius
Then you
squared.
You square root.
You square root it.
Square root both sides then.
Yep. And when you square root a fraction,
It'd be.
you square root the top and the bottom separate.
I did not know that.
Yep, that's how you take the square root of a fraction.
That's crazy.
What's the square root of 64?
6.
8.
That'd be 36. So yeah, square root of 64 is 8
I can't do simple math.
over the square root of 3. Technically, we're not supposed to leave the square root in the bottom. I'm okay with us doing that for now. Eventually, I'm going to show you how to fix it. But I need a label.
Inches?
Yeah. So my original length unit was inches squared for area.
Radius is just inches.
But in this problem, it's inches. Yep. So that's the 2 formulas in that section. And R is the hardest one to solve for because you have to take the square root. So we did the hardest one. So that's the homework.
How about none of that? Yeah.
So it's 71 to 87 odds
What unit is it?
and 91 to 93 all. This is section 2.1. So it's the same PDF as last time, just the next page.